Welcome back. We are now on page 49 of the notes. This is the final page of section 7.3 in the notes. However, in the next video we're going to be doing some extra problems still related to these, so you'll have a little bit more practice. But for right now, let's rotate about a horizontal axis which is not the x-axis. Okay, so what we're going to do is we're going to find the volume of the solid obtained by rotating the region bounded by the curves y equals x cubed, y equals 0, x equals 1, about the line y equals 1. So let's draw a picture. We're going to get, first of all, here's our axis up here at y equals 1. So let's say this is 1. And y equals x cubed starts at 0, 0, and it kind of has a parabola shape. It's a little bit flatter to start off with. So it's kind of more like that. And now what we're going to do is you'll notice that x equals 1 is forming the right part of our region. So in fact, this is the region that we're rotating about this line here. And so switching to red, the picture we're going to get is something like so. Okay, and our observation here is that we need all of our functions, everything to be in terms of y. So y equals x cubed is not good enough. We need to change that to x equals the cube root of y, which I'm going to write as y to the 1/3 power. Okay. Now, let's switch to blue and see if we can find our cylinder. So pick a y value. Then this is the height of our cylinder. And so when we rotate it, we're going to get something that looks like this. And here we go. Okay, so the radius of the cylinder, let's set up the volume here. So we get integral 0 to 1, 2 pi. Now the radius of the cylinder is going to be 1 minus y, right? It's you notice as y gets bigger, our radius gets smaller. So that's 1 minus y. And now the height of the region of the cylinder is given by this little sliver right here. Well, we see here that it's fixed at 1 being the quote-unquote upper function, and the lower function is formed by x equals y to the 1/3. So it should look like 1 minus y to the 1/3. All right, so now it's a matter of just expanding this out and then integrating from there. So this is the integral from 0 to 1. Again, those are the y bounds of the region. 2 pi, parentheses, we get 1 minus y to the 1/3 minus y plus y to the, it looks like 4/3 power. Okay, so now to integrate this, we get 2 pi y minus, now increase the power by 1, divide by the new power. So our new power is 4/3, so when we divide by that, we get 3/4, and minus y squared over 2, and plus increase the power to 7/3, and divide by that, which is the same as multiplying by 3/7. And now just plugging everything in, we get 2 pi. Plug in 1, you get 1 minus 3 over 4 minus 1/2 plus 3 over 7 minus 2 pi. Then when you plug in 0, each of those is 0. So that's all gone. And so 1 minus 3/4 is 1/4, minus 1/2 is minus 1/4, our common denominator looks to be 28. The 1 needs the 7, and the 3 needs a factor of 4. So you'll notice a 2 will cancel with the 28 to give 14 on the bottom, and we get 5 on the top. So this is 5 pi over 14. All right, so now we're going to work backwards. So we're going to look at this integral and see if we can determine which, like the sort of solid we get that has this volume formula here. Okay, well, we see everything is in terms of x. So since we're using shell method, we must have a vertical axis. Everything is in terms of x. So now it's just up to us to decide what that is. So it looks like the upper function is going to be cosine x. So here's pi over 4, let's say. And then pi is going to be way over here. And that's where we're rotating. And the reason I know that is because as my x value moves between 0 and pi over 4, the larger the x value I have, the smaller my radius is getting. So I must only be moving between 0 and pi over 4 and getting closer to my axis for larger x values. Now, cosine starts up at height 1, sine starts up at height, starts down at height 0, and they meet here at pi over 4 at root 2 over 2, where their values are the same. So this is the region, and we're spinning it about this axis. So you can see we get some strange shape when the rotation is done. But this is all we were supposed to do, is find the region and describe what's happening here. All right, in the next video we're going to have a little more practice, and then that'll be the end of essentially our Chapter 7 notes.